let us understand the meaning of electron gain enthalpy. Now, suppose we are having this nucleus and shells are there around. So, this is an atom which I have drawn. Okay. Now, in this atom, already we are having 1, 2, 3, 4, 5, 6, 7. Now, we are having 7 electrons, and this is just an example that there are 7 electrons present, and we are going to add, okay, I am writing plus, we are going to add 1 electron. Now, see, already there are 1, 2, 3, 4, 5, 6, 7 electrons are there, and the 8th electron we are going to add. Now, when you add a new electron, what happens? Initially there is repulsion. There is repulsion between the incoming electron and existing electron. Now, due to this repulsion between the incoming electron and the existing electron, even though the effective nuclear charge is more, this electron will be accepted. Okay, but when it will be accepted, two things are going to happen. Number one, please remember, two things are going to happen. Number one, when the electron will be added, the energy is released from the atom. Now, second point, see, why energy is released? Because there is a repulsion, okay, and hence energy will be released. But second point, now see, when this electron is added, suppose I add this electron over here, okay, so there will be the repulsion between incoming electron and the existing electron. So what will happen? This electron will shift ahead, hence this next electron will shift ahead, this will also shift ahead. So all the electrons will try to shift ahead, and in doing so, the outermost shell, okay, the size, it just expands, okay, and hence students, we say that after addition of electron, see, the atom becomes anion, and anion is having greater size, it is larger in size as compared to its parent atom. I hope you have understood this particular point. So first is energy will be released, and second is the size of the anion, that it was earlier atom, but now the size of anion increases, okay, to overcome repulsion. Alright, now, so we are going to study now what is going to happen to the electron gain enthalpy of the elements across the period and down the group. Okay, so let us begin with this. See, electron gain enthalpy, it is the enthalpy change, that is the energy which is released, that takes place when an electron is added to the outermost shell of an isolated gaseous atom. Okay, now it is designated by delta EGH. So students, number one, what happens across the period? Okay, now these are the common points which you will have to remember, that across the period, number one, atomic size decreases, okay. Second, effective nuclear charge increases. Third, electronegativity also increases. Electronegativity is the tendency of the nucleus of an atom to pull the electron towards itself. So all these parameters are increasing, and hence what is going to happen now? Electron gain enthalpy, more energy will be released. Electron gain enthalpy, more energy will be released. Electron gain enthalpy increases, that is, the value will be large. Okay, now you can relate this point with the last point. If atomic size decreases, it means nuclear charge is more, and the nucleus is pulling the valence electron towards itself. In such a shell which is having more electronegativity, in such a shell you are going to add the electron. So when you add such electron, there will be repulsion, and because of which the energy will be released. Okay, now what happens down the group? Let us discuss what will happen down the group. Point number one, down the group, what is happening, students? Atomic size increases. Second, if atomic size is increasing, even though nuclear charge increases, but it is not having any effect on the valence electron. Okay, so what happens? The last electron, okay, is already loosely bounded, Fine, it is already loosely bounded to nucleus. सो इट मीन्स न्यूक्लियस को कोई फ़र्क ही नहीं पड़ता है, आप लास्ट में इलेक्ट्रॉन ऐड करो या रिमूव करो, वेरी लेस एनर्जी विल बी रिलीज्ड, वेरी लेस एनर्जी इज रिलीज्ड. इसीलिए वी से दैट डाउन द ग्रुप, okay, down the group the electron gain enthalpy, E gain enthalpy, okay, it goes on decreasing. Fine. Now, what is electronegativity? It is the ability of the covalently bonded atom to attract the shared pair of electron towards itself. Now, students, what happens across the period we have to discuss. Okay, across the period, as we have already discussed, that atomic size goes on decreasing. Second, atomic size decreases, so effective nuclear charge increases. Third, what is happening? Nuclear charge is increasing. It means nucleus is pulling the valence shell or the valence electron towards itself, and hence we say that En, that is electronegative value, also increases. So across the period the electronegativity increases. Let us write these points over here for down the group. Okay students, for down the group. Down the group what happens? Atomic size decreases or increases? Increases. Second, effective nuclear charge increases, but it is not having any, it overcomes, it is not having any value. Okay, not effective. I'll just write not effective. Okay. Third, electronegativity decreases because the distance between the nucleus and the last shell is more. Hence, the tendency to pull the electron goes on decreasing. So, if I have to answer across the period, I'll say from lithium till fluorine, the electronegativity goes on increasing, and from lithium, if I come down to cesium, the electronegativity goes on decreasing. I hope you have understood this concept very nicely, but yes, there are few exceptions, okay, for electron gain enthalpy and electronegativity. We will discuss these exceptions separately in a video, separately in a Now, what is the meaning of valence? See, I have already written definition that the number of chemical bonds that the atom can form giving a molecule. Don't worry, I will explain this definition with the help of example. Okay students, so group number 1, 2, 13, 14, 15, 16, 17. We'll just write the electronic configuration. Okay, we all know it is 1 and this is going to be 2, this is going to be 2, 8, 1. Okay, 2, yes, what it would be? 13 it is, so it is going to be 2, 8, 3, sorry, it is 2, 8, 4, it is 2, 8, 5 and 2, 8, 6 and it is 2, 8, 7. Now, will you be able to identify students the number of valence electrons? Yes, here it is 1, here it is 2 and in this case it is 3, 4, 5, 6, 7. Okay, so I'll just write here 3, 4, 5, 6, 7. Okay, now I write over here valency. Okay, before valency I'll just write if it has to combine with hydrogen, then what we are going to get. Okay, if it has to combine with hydrogen, what we are going to get. So this is lithium, this is beryllium, this is boron, carbon, then after carbon what comes? We are having nitrogen, then oxygen, then fluorine. Okay, or you can remember sodium, magnesium, okay, Nam-G, this aluminium, silicon, phosphorus, sulfur and chlorine. Now, because I have written electronic configuration in this way, see I have written 1, 2, so it is better that I mention, I take example of sodium, okay, I take example of sodium, fine. Now, so I'll have to write here, it is 2, 2 I'll write, and magnesium it is, so 2, 8, 2, okay, sodium is 2, 8, 1, I'll just write here 2, 8, 1 and 2, 8, 2, okay. Now, because I am taking example of sodiums, I have done some changes in this, alright. If you take example of lithium, beryllium, carbon, then this will change, alright. Now, so we are going to opt for sodium. This where I have made star, you concentrate here. So I have written 281, 1 valence electron, 282, 2 valence electron, rest is same, that is 3, 4, 5. Now valency. To explain the concept of valency, I am just giving one example of hydrogen. If sodium has to combine with hydrogen, then what will happen? Hydrogen is having only one electron, and sodium is also having only one electron. So they will share their electron and we will get sodium hydride. Okay, next, magnesium is having two valence electrons. Okay, so what will happen? In order to have stability, magnesium will gain two hydrogen atoms. Okay, now aluminium. Concentrate on this aluminium. Three valence electrons are there, so aluminium will accept 3 hydrogen. Now in case of silicon, what is going to happen? Si, 4 valence electrons are there, so it will accept 4 electrons from the 4 hydrogen atoms. Okay, that is each hydrogen atom will contain 1 electron. Now students, just concentrate on phosphorus, sulfur and chlorine. Okay, we have phosphorus with the 5 valence electron. Now what happens if it wants to achieve stability? It is going to lose 5 electron or gain 3 electrons. See, if it is losing 5 electron, it will achieve octet state. But if it is gaining 3 electrons, then it will achieve octet state. Now losing 5 electron requires more energy, but gaining 3 electron requires less energy. So hence the element that is phosphorus or nitrogen or group number 15 onwards, they are known as non-metals because they gain the electrons. Okay, so how many electrons they will gain? Whatever is the number of electrons required to achieve octet state. It requires 3 electrons, so it is going to accept 3 hydrogen. Okay, now let us come here. Sulfur is there. So sulfur is having 6 valence electron. It requires only 2 electrons to complete its octet. So it will accept 2 hydrogen. Similarly, chlorine is having 7 electron. It requires only 1 electron to achieve octet state. So it will accept only 1 Ca, H. Okay, only 1 H. Now, so if you focus now on the definition of valency, students, what would be the meaning of valency or valence? Just focus over here. It was easy to lose 1 electron. It was easy to lose 2 electron. It was easy to lose 3 electron. And it is easy to share 4 electron. It is not going to lose, not going to gain. Okay. Now, so number of electrons which are lost or gained or shared in order to achieve the stable inert gas configuration, in order to achieve stability, okay, that is known as valency. Okay, I repeat, number of electrons. Like sodium, over here its valency is 1 because it is losing 1 and achieving stability. Beryllium or magnesium you take, it is losing 2 electrons and achieving stability. So what is valency? It is the number of electrons which are lost. Okay, I'll just mention over here, number of electrons which are lost or which are gained or which are shared so as to achieve the stable inert gas configuration. That number is known as valence. Okay. Now, I'll just give one more example of oxygen, students. Okay. With oxygen, what will happen? Alright. Now, let us take example of lithium now. Okay. I'll just write here lithium, lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. Okay. Now, concentrate on oxygen. Oxygen is what? 2, 6. Fine. 2, 6. Now, in this case, see, lithium is, what is the valence electron in case of lithium? In case of lithium, valence electron is 1. In this case, valence electron is 2. Valence electron is 3. Valence is 4. Valence is 5. Valence is 6. Valence is 7. See, I am just repeating this. 1, 2, 3, 4, 5, 6, 7. Okay, I just wrote the valence electrons. Okay, so I'll just mention here, these are the valence electrons. Okay, now look at the oxygen. Now, lithium has 1 valence electron. Okay, so lithium is going to take oxygen, but oxygen is having 2 valency. It means, why 2 valency? Oxygen requires 2 electrons to complete its octet, isn't it? 6 is there. If it takes 2 electrons, then oxygen will be stable. Hence what happens is lithium Li, okay, oxygen requires 2 electrons. So oxygen will gain 1 electron from one lithium, second electron from the second lithium, and hence the formula is Li2O. Alright students. Now beryllium, it is having 2 valence electrons. So what is going to happen? It is having tendency to combine with oxygen. So BeO. Okay, because oxygen also requires +2 and beryllium is going to lose 2 electron. So BeO. Okay, now here what will happen is boron. So B2O3. Okay, in this case CO2. In this case N2O3, because the valency is +3 over here. Okay, why +3 students? It requires 3 electrons. Okay, oxygen, it requires 2 electrons. Okay, now this is very easy. It's a compound which you will get, that is O2. And F, what we are going to write for F? We are going to write for F, that is OF2. Now the meaning of metallic character. See, tendency to lose electron. Tendency to lose electron is also known as electropositive character. Okay, so metallic character is this. What is non-metallic character? Non-metallic character is tendency to gain electrons, and this is known as electronegativity. Okay, now we are going to discuss what happens across the period. Alright, now students, across the period we all know that atomic size goes on decreasing. Atomic size goes on decreasing, electronegativity goes on increasing, and if electronegativity goes on increasing, nucleus is able to pull the valence electron strongly towards itself, and hence it cannot lose electron. Okay, and hence it cannot lose electron, its metallic character decreases. Okay, whereas down the group we will discuss. Down the group what happens students? Down the group atomic size goes on increasing. Okay, second, if electronegativity goes on decreasing, and third, if electronegativity goes on decreasing, the tendency to pull the electron will go on decreasing. So non-metallic character will also decrease. But yes, we can add one more point over here. What will happen to the non-metallic character? Non-metallic character, see, it is going to be opposite. Metallic character decrease हो रहा है, मतलब लूज नहीं कर सकता वो इलेक्ट्रॉन. लूज नहीं कर सकता क्यों? क्योंकि एटॉमिक साइज कम हो गया, इलेक्ट्रोनेगेटिविटी बढ़ गई है, तो टेंडेंसी टू पुल दी इलेक्ट्रॉन बढ़ गई है. इसीलिए अक्रॉस द पीरियड नॉन मेटालिक कैरेक्टर बढ़ेगा. ग्रुप नंबर 17 जो है वो बेस्ट नॉन मेटल्स होते हैं. ग्रुप नंबर 18 के लिए तो एप्लीकेबल नहीं है, बिकॉज दे हैव ऑलरेडी अचीव्ड स्टेबल इनर्ट गैस कॉन्फिगरेशन. सो आई जस्ट राइट ओवर हियर दैट द मेटालिक कैरेक्टर विल गो ऑन इंक्रीजिंग. जैसे जैसे हम ऊपर से नीचे आएंगे, देखो डाउन द ग्रुप, जैसे जैसे हम पीरियोडिक टेबल में ऊपर से नीचे की तरफ आएंगे, एटॉमिक साइज बढ़ता है, इलेक्ट्रोनेगेटिविटी कम होती है, और मेटालिक कैरेक्टर बढ़ता है. मतलब इजीली इलेक्ट्रॉन्स कैन बी लॉस्ट, बिकॉज साइज जो है एटम का वो बढ़ गया है. न्यूक्लियस का जो ध्यान है लास्ट वाले शेल में, लास्ट इलेक्ट्रॉन पे ज़्यादा नहीं है, तो ऐसे इलेक्ट्रॉन विच आर लूजली बाउंडेड टू द न्यूक्लियस कैन बी इजीली लॉस्ट, गिविंग टू more metallic character. So finally we have arrived at a point wherein, or at a stage wherein we have to discuss what is happening across the period to atomic radii. You can pause the video, you can make this chart, and you can put the arrows increase or decrease. Let us solve together. Atomic radius across the period goes on decreasing, down the group goes on increasing. So students, every point is related with atomic radius. What happens to ionization enthalpy? Across the period it goes on increasing, and down the group it goes on decreasing. Okay, electronegativity across the period goes on increasing, down the group goes on decreasing. Electron gain enthalpy goes on increasing and goes on decreasing. Yes students, there are some exceptions, we are going to discuss them in the separate video. Metallic character across the period goes on decreasing and metallic character across the period decreases and down the group it increases. Non-metallic character across the period goes on increasing and down the group goes on decreasing. So I hope this video was useful to you. I have tried my level best to make the concepts easier. If you have understood the concept, do like the video and share this with your friends also. Thank you.